often said the FOP world is the way the United Nations should be. Everybody is working together in their own way. The families in every continent, the doctors, the scientists are all working together.
It's always important to remember that it's not one person, it's really a team, and lots of people talking together, sharing ideas, sharing opinions.
We recently had a meeting in Europe with colleagues who are interested in FOP and realize that now the techniques are available and the interest is there internationally to catalyze this effort and to find the gene. So we're very, very delighted to have welcomed in this past year into our international collaborative research effort scientists from Oxford University in England.
I had 2 or 3 of these bays initially with about 10 or 12 people working in the early days when we first moved to the Botner. The Botner Institute is the major musculoskeletal science centre in the UK. Certainly it's very nostalgic to come back into the lab and remember what we were doing all those many years ago. My name is Jim Triffitt. I'm Emeritus Professor of Bone Metabolism at the University of Oxford, interested in all aspects of bone physiology and biochemistry, particularly in bone cell differentiation, which is related, of course, to fibrodysplasia ossificans progressiva. In the early days, in the 1970s, there was very, very little known about the condition. The burning question to answer about FOP at that time was really what is the agent that causes this? Is it part of this BMP pathway? And how could we investigate this? It was really a conundrum with very few tools available at the time to make advances in treatment for these patients.
Jim Triffitt has given his life over to the FOP community, travelled the country meeting FOP families to help inform his understanding and his learning. And he's just as passionate about FOP now as he was when he was a very young researcher.
It was a passion to be able to help, but of course, because it's a rare disease, there was very, very little input of funding from major government agencies at that time in the UK, and all the work that we were doing was being financed by the patients and their families.
It is thanks for all those really motivated early families who thought, right, we can actually do something here. Here's what we can do, whether that's give money, give time, and that has meant, and even though we were told slightly incorrectly that we'll have a treatment within 5 years of our diagnosis, it means that when we turned up, there was real hope for a treatment, for a cure, for something life-changing for FOP families in the community.
The Botner Research Centre was completed around 2002. We were all colleagues in this new building, one of which was Professor Matt Brown. He wasn't professor then, but I knew that Matt was looking at the new genetics. This was in the early 2000s.
This is the bay that Matt Brown had.
Yeah. Matt was using these new and highly sophisticated computerized technologies to define where a gene and a trait or a feature of a disease would be inherited. I persuaded him that FOP was something that would be good for him to look at.
Jim went out of his way to engage with me and to introduce me to the world of FOP. The disease that I was actually doing my doctoral research on is a condition called ankylosing spondylitis, which is not a rare disease, it's a common disease, but it causes bone formation up and down the spine in relation to inflammation. So this link between inflammation and bone formation is actually, you would think, quite similar to what actually goes on in FOP. And so therefore Jim thought actually it was quite relevant for me to actually be engaged in the FOP research.
It wasn't too difficult to encourage Matt to join the team, making him aware of FOP and how important it was to the patients and families that some new knowledge about the condition would make such a significant difference in their lives.
FOP is one of those conditions that really gets into your soul. You see families affected with this absolutely devastating and terrible condition who are so caring and supportive for their affected children. Affected children try to get on as much as possible with their lives despite being affected with terrible afflictions which are of their own, not of their own making. And so for that reason it's something that really gets to you emotionally, and that's a major reason why I've stuck with it for all of these years.
The exciting thing about the new genetics technologies was that it was possible to look at low numbers of families and be able to get some idea of the location on a particular chromosome that would harbour the gene that caused FOP.
When I started working in FOP, there were different groups working in different countries working on the disease. And rare disease genetics, unfortunately, often was a bit of a winner-takes-all race where you had groups competing with one another to try and identify the disease-causing gene and not collaborating that much because they wanted to be the person who identified the gene first. The problem with that approach is that if there are not very many families to study to go round, then any individual group may not actually have enough families to be able to identify the disease-causing gene. And that obviously is not to the benefit of the patients and the families who just want you to identify what's causing their condition.
When we decided with Matt that this would be a possibility for using the new genetics to look at the FOP gene location, we arranged a telephone conversation with Fred Kaplan and Eileen Shaw. In those days there wasn't any Zoom, but it was just on an ordinary telephone conversation.
Jim and Fred Kaplan in particular got together and agreed that there would be collaboration between the UK and the United States, and through Fred's links more broadly than that around the world. And most of the researchers in FOP genetics around the world joined this group and shared families and DNA samples from all of their multi-case families so that we could then filter down and decide on which families we'd ultimately end up staying. So this is quite different to many other rare diseases, and it was really the key breakthrough for success for FOP that there was this international collaboration.
I think the FOP gene story epitomises the best way science can happen to achieve the best possible outcomes for everyone.
It was a matter of building a community, building a world community, building a United Nations of FOP, and that's really the story.
We have to remember how hard it was to actually map genes for rare single gene diseases back in those days. Not very many diseases had actually been mapped and the rate of progress was slow. The difficulty is illustrated by the fact that actually incorrect chromosome locations were identified for or reported for the FOP gene, in particular, for example, one on chromosome 4. That was actually one of the triggers for us reaching out to Fred's group, because we had data from British families which showed that the chromosome 4 location was incorrect. Some of the families that were identified were probably cases where we had mosaics, where people had mutation in the disease causative gene who appeared healthy because it actually only affected a subset of their cells. And therefore that made mapping the gene quite difficult in those families, and in fact quite often inaccurate. So we went back to Fred, and Fred, to his eternal credit, actually then shared all of the data with us, which we were then able to work with together.
Finding more multi-generational families, Eileen and I spoke to Jim and Matt, and we said, let's look at just the families that have absolutely the classic FOP.
Only those which were definitively known to exhibit all the features of FOP should be included in this analysis.
The major breakthrough was that Fred in particular, working with Aileen Shaw, were able to come up with a very clean set of families which we're able to then use for mapping. The method that we used to map the FOP gene was something called linkage analysis. Linkage analysis looks at whether markers that you are studying in different individuals in a family are inherited from one individual to another individual in association with the disease. Having come down to these 5 clean families, then we were able to show that there was this region on the long arm of chromosome 2 which was linked in all of those families to FOP.
I remember Matt came home absolutely thrilled, and the bit that he was working on, he said, I think we've solved it.
It's in some ways easy to generate data. It's not and vast amounts of data. It's not always easy to process that data and interpret it and make sense out of it. And that's really, where Matt came in. He was the one who was able to, tie all these pieces together and identify that common linkage interval.
When this location was discovered, it was really one of the most exciting things. Now we had a concrete place to look.
Looking at individual genes to say, is the mutation in this gene, is there a mutation in that gene?
There were around 120 known genes in this area.
Progressively, the human genome map was actually identifying genes across the genome. And so at some point, people actually started annotating or naming genes that lay within the recombination region, the region that we'd identified that's linked to FOP.
The first step was to go to these databases and look to see what was known about any particular gene. So when we were looking at our selection of a few hundred genes in our linkage region, we were really happy to see that there were some genes that had connections to the BMP signaling pathway.
There was one particular gene that stood out to me, and that was ACVR1.
One of those was ACVR1.
In the middle of it was ACVR1.
And so we narrowed it down immediately from 100 down to 1. And that's the gene that we gave to Mei Chi. We said, look at this gene, look at ACVR1, and bingo.